How do you architect an AI-driven application that uses both LLMs and traditional ML? When you blend an LLM with traditional machine learning, the key idea is to give each system the part it does best. Think of it like building a hybrid vehicle. One engine handles flexible language tasks. The other handles fast, structured predictions. A strong interview answer sounds like this. You architect a hybrid pipeline where language understanding, summarization, and reasoning flow into the LLM, while tabular forecasting, anomaly detection, and numeric scoring run on classic models. The benefit is simple. You get the creativity of language models and the precision of structured ML without forcing one to do the other's job. Interviewers may ask how you avoid conflict between the two. You explain that routing logic decides where each input goes. Don't worry if it feels abstract. By the end, you'll see how the parts snap together like puzzle pieces. The core architecture strategy. A helpful way to understand the core architecture is to picture it as three layers working side by side. First is separation. The LLM takes anything messy or text-heavy, while the classic models take structured fields, numbers, and time series data. Now build on that. Your data pipeline becomes a traffic controller, steering each request to the right engine based on complexity and format. And here's where everything meets. The integration layer acts like a conductor, coordinating both systems and using a shared feature store to keep inputs consistent. In interviews, this is a strong answer because it shows clarity of roles. A common follow-up is why separation matters. You explain that it prevents overloading LLMs with tasks they aren't cost-efficient for. This mindset shows maturity as an engineer. Implementation workflow. A simple way to visualize the workflow is to imagine a branching road. At the entry point, you separate structured and unstructured inputs. We see, then, intelligent routing checks what each request truly needs, almost like a receptionist guiding visitors to the right office. From there, both engines run in parallel. The LLM handles reasoning or text generation. The ML models deliver fast, numeric predictions. Finally, everything comes back together through aggregation, where you combine signals into one clear answer with weighting logic. Interviewers often ask how you prevent slowdowns here. You explain that parallel execution keeps latency under control. Don't worry if this feels like a lot. Once you build a few pipelines, this flow becomes second nature. Key follow-up questions and answers. A helpful way to think about choosing between systems is to match the tool to the shape of the problem. LLM shine for conversation, rewriting, and semantic understanding. Traditional ML excels with tabular predictions, forecasting, and scoring patterns. To optimize cost, you might cache repeated LLM responses or use smaller models for simpler tasks. When latency comes up in interviews, you can explain that async processing and pre-computed ML features keep the system responsive, with fallout logic when the LLM is slow. For monitoring, treat the two engines as separate athletes. Track their accuracy, response times, and drift individually. Many learners miss this separation. Keeping them distinct makes debugging far easier. Production pipeline, data to deployment. The production pipeline flows like a carefully staged relay race. You begin by collecting and cleaning data so both engines receive reliable inputs. Next, you engineer features for ML while also preparing prompt structures for the LLM. Then, each model trains in its own environment. The ML models learn numeric patterns, while the LLM is fine-tuned on domain language. During inference, an orchestrator routes requests and merges outputs smoothly. Deployment uses containerized services with auto-scaling, so peaks in LLM usage don't overload the system. Finally, continuous monitoring acts like a dashboard. It catches drift early and kicks off retraining jobs. Interviewers love this lifecycle answer because it shows you understand not just models, but the full production reality. Great job learning today. If this helped you feel clearer or more confident for your AI or ML interviews, tap like so more learners can find you. If you want simple guidance for every interview topic, subscribe so you never miss the next lesson. You can share your questions in the comments. I read them, and they help me choose what to teach next. And if you know someone preparing for interviews, feel free to share this with them. Keep going. You're improving with every step. I'm here to help you grow.